So Cam found it helpful that we take this because when he went to his music lesson, he looked at our virtual classroom and was able to do all the work.
I heard everybody's voice in music.
You can hear the voice.
Yeah.
They're quite talkative in here, right, for the little group? All right.
I heard Single's voice too.
Sorry.
He was dumbfounded. He was like, what? What? I heard that.
Okay.
It's like a little yearbook.
Tell me if you have any questions. Is anybody not able to do this? This is on the unit circle. This makes life a little bit easier. This is the x, this is the y. So the x is automatically your cosine, and the y is automatically your sine. Your tangent, you just have to put y over x. Because they're the same denominator, when you do keep, change, flip, the denominators cancel out. Wait, this didn't have a negative. So now the denominators cancel out. So automatically, like we call this like just compress it down. If the denominators are the same, they're going to compress down. And then take these values and take their reciprocals. Don't leave me the 1 over anything because that's a complex fraction. This also was on the unit circle, so the r is equal to 1, therefore the x is the cosine, the y is the sine, and again, flip your tangent. Good? Oh. The unit circle is nice because when you take the sine and you do y over r is 1. God bless you. R is 1, so it just becomes equal to y. That's a good one to get under your belt, that when you're on the unit circle, the sine is the y, the cosine is the x. And the tangent is just the y over x. The rest of the other three, just flip them over. Those are their reciprocals. This one, you had to find all your trig values. We didn't put this on the circle. If you recognize this, this came out of the book. I left this here, although I wouldn't use this. I left this here so that maybe you kind of saw that they kind of tried to reduce this. I don't know. They divided by 4 for some reason. I don't know why, but if you notice that that happened to be your 3, 4, 5 triangle, that might be something good to look at. I think they were geared to, let's do this sine cosine with this one and make sure they reduce to the same thing, but I didn't do it that way.
They did reduce this.
Yeah.
I got like 1.5 over 2.5, which is the same.
Yeah, but don't ever leave a decimal in there. No decimals in your fractions. When you do this, like this is, they did opposite over hypotenuse and adjacent over hypotenuse, just to make you think in terms of that a little bit. When you do this, if this is your opposite, even if you wanted to put this on a grid and make this be your y, make this be your x, when you do this, before you do all your functions, reduce it here. This is far easier. If you notice they're all multiples of 2, reduce them here. And then you won't have to reduce them at the end. Because what happens is you'll have to reduce each one. You'll have to reduce them all down 3 times. So just reduce it once. Because you always need lowest terms. Okay, and no decimals in your ratios. Okay. Like they told you a quadrant, they have to tell you a quadrant because sine is positive in 1 and 2. But cosine is not. So they have to tell us what quadrant we're in. Figure out the missing side. Now be careful with Pythagoreans because sometimes you're missing the radius, the hypotenuse, and sometimes you're not. In this case, we weren't. Leave your radicals in simplest radical form. Okay. Yes, I'm just saying in case it's not, leave your radicals in simplest radical. You know you don't have to rationalize any denominators, so you're okay there.
Except on the back, they rationalize ones.
Sometimes they do, yes, because you have to unrationalize that one to get to your answer. They tried to get you. Shh, guys, come on. Any questions? So if I give you a quiz, everybody's on track here.
Yes.
So tell me where. Is everybody okay with this? Ryan, good? Okay. No, the real Ryan. Not you, Jordan. The real Ryan. I'm not so sure about this routine. Okay, again, Make a ratio, 3/1, find your y, x, find your r, and just make your things. I know this was a little repetitious, but sometimes repeating things helps you get the routine for something. When I'm given a function, and I need to, we were told we were in quadrant 1. When I'm given a function and I need to find my missing part, and then do all 3, if you do it a couple of times, it starts to sink in a little bit better. So then when I see something weird, it'll still fit the pattern. These were kind of all different types of things. I'm really just doing basic trig, bringing you back to your basic trig.
How do you know it's in quadrant 1?
How do I know what? The direction said, I think, up here. For all 6 values for quadrant 1. We would have to tell you if it's not, because tangent could be positive in 1 or 3. Okay. Oops. These guys again, these are in quadrant 1 because we said your angle came between 0 and 90, or 0 and pi over 2. So they were all in quadrant 1. We had to find the angle and then name it in radians. Is everybody okay switching to radians without using your formula in all your quadrants?
Yeah.
Okay.
See how many times it goes into 1 meter.
Yep.
And then work from there.
Yep, work from there. Make the same numerator denominator on the 180 and double it on the 2 pi. All your triangles will only go up 1, down 1. If it goes up 2 on a 30, it becomes a 60. And 45 is nice because it cuts the quadrant right in half. It can only go up 1, down 1. Then it hits the quadrant angle. No questions? Everybody good? Everybody remember those special triangles?
I don't understand how to do those.
Okay, so these guys, you can do it the same exact way. Or you can realize that they rationalize. Whatever gave me this here probably was down here. So if I unrationalize this, it makes it appear like a special triangle. If not, you can still do the same thing. This is the reciprocal of sine. So sine is y over r. So this is going to become r over y. So you can do it the same way. You can still find the missing x, and then when you set it up, you're going to have to reduce it. It'll still work the same way. You're just going to have to reduce it at the end to see the function. You can also, in your calculator, you can also do, well, I don't know if you can do the reciprocals. You can just flip this over and do the sine one, and make sure that it's a 60-degree angle. They kind of, like Ashley said, they rationalize this one. And this one, right, isn't this one familiar for our 1 over radical 2? Because last year we always said radical 2 over 2 for your 45s. They you just have to unrationalize them. Because we never really come out with this in our numerators. A 2, a radical 3 maybe, but not a 2. Just so that you're kind of remembering all the different parts of your trig.
They just try to keep you on your toes.
When you're given an angle, don't forget, these all start here at the positive x and they rotate counterclockwise if they're going to be a positive angle. If they go the opposite way, clockwise, they're going to be a negative angle. So you need to find all 6 functions. Now an easy way to do this, drop your triangle, there's your x, there's your y. So label these parts. Now, on your triangle, I don't care if you put the positives or negatives, build it up over here so that you can use these pieces. Call this your information box. Do you know what your radius is? Do you know what your radius is? If one side is radical 3 and one side is 1? 2. This is your special triangle. What angle is in here, in this reference angle? What's opposite the 1? 30. So what angle goes all the way across here? 210. I didn't ask for the angle, but I just did. So in radians, how do I name that in radians? So how many times does 30 go into 180? 6. 7 pi over 6.
She's talking about 180.
Oh, okay.
Make this be your pi. This is your pi, right? Make
Yeah.
these be the same and make these double, just on the numerator. So if my angle was over here with the 30-degree reference angle, what would my angle be?
11 pi over 6.
11 pi over 6.
Sure.
Get used to that pattern. Otherwise, you're going to have to convert all your angles using your formula.
How do you get 6 over 6?
6 over 6 because this is pi. So if I take pi and I want to convert it to a denominator of 6,
I know, but how do you know you want a denominator of 6?
because it's a 30-degree reference angle, so 30 goes into 180. When you do this and you multiply it here, you essentially say this. 30 goes into 186 times. If I do 45, if I'm using your formula, 45 goes into 184 times. And 60 goes into 180 3 times. 90 goes into 180 2 times. So this guy is pi over 2. If this is 1 pi over 2, look, this is 2 pi over 2. This is 3 pi over 2. This is 4 pi over 2. Make sense? You get used to working with a pattern, and you don't have to convert them in your head. So that's what those are looking at. So that we kind of, excuse me, we hit one of each. All right, let's hit this guy. Let's hit number 17.
We even do the...
No, this is your homework. I'm just doing one of each, so you're going to do the next one. But you can do all the trig functions.
Okay.
You can do all the 6 trig functions after that, right?
Yeah.
I'm just helping you get set up a little bit, just so that you understand what we're asking. Everybody was okay with setting up their functions, right? Your 6 trig functions. We just asked a little bit more of that. We played with that one a little bit more. Once you have this, all your x, y, and r, your trig function should come out really easy, right? It has all your negatives and positives in there as well. So if you say the sine of this angle, y over r. Take your y over r. You get all your negatives and positives at the same time. And you can do the rest of those. So number 17. What quadrant would I find the point 5, negative 12? Quadrant 4. 5, negative 12. So somewhere, I started an angle, I opened up my angle, and I terminated here. This is where I terminate. It's the terminal side of my angle. So my angle, I drop a triangle to the x-axis, and I label x and y. 5 and 12. Now I have to find r. How do I find r, the missing part? Pythagorean theorem. And does anybody recognize this one? 13. This is one of your triples. Or you can absolutely do 5 squared plus 12 squared equals r squared.
Do you have to, like, if it's a triple and it's a known triple, you don't have to, like, show that
No,
part, right?
but no, because that's a triple. Yeah, there's a couple that you'll see 7, 24, 25. There's a couple that you'll see over and over again.
But if it's a triple, we don't have to show...
No, no. And then from there, can you do all your sines and cosines trigs? All your trig functions? You only got to do the 3 for these guys. Okay, is this a unit circle I'm working on? No, because my circle, my radius is not 1, right? Okay, so that's not a unit circle. So, state what quadrant the angle lies. Take it apart. Where is sine negative? 3 and 4. Okay, where is cosine negative? 3, and where else? 2. Think of it this way, the cosine is your x. Here's your x negative. So this quadrant, this quadrant. Now, where they overlap is where it meets both criteria. So what quadrant would I find that angle in? 3. doesn't that make sense? The sine is negative, the y is negative, the cosine is negative, the x is negative. And your tangent always comes out positive. Quadrant 3. So you can do those.
I
Right?
like these.
Those were nice little 2-point questions on your regions.
Yeah.
Okay. This we should be able to do. Only I told you what quadrant it lies in. It doesn't always lie in quadrant 1. So why would I need to tell you that? Why did I have to say quadrant 2?
Because then cosine and tangent will be negative.
Yes, it's going to affect the cosine and tangent. If I put everything in quadrant 1, then everything becomes positive. So now my angle is going to terminate in quadrant 2. And this is going to be my y over r. So what's my x value?
Square root of 4, so 4.
4.
Well, it's in
3,
So
3, 4, 5, right? So x in this quadrant is negative, y in this quadrant is positive, and r is always positive. So from there, can you find your 3 functions? You only had to find the 3. I figured you kind of get the hang of the reciprocals, so why annoy you the whole time with that? Okay, and so that you should be able to do the next few. Find the exact values. Let's hit one of these. So let's hit 225. What quadrant would I find 225? Third. Terminates here. What would my reference angle be? If this is 180 and this is 225, 45. So then you can fill the rest of it in, right? Where would I find negative 17 pi over 6?
Oh, I like the blue.
5, 10, so
It's going to go the negative. So if this is 6, this is 6 pi over 6. This is 12 pi over 6. Coming back again, if I add 6 to 12, what do I get? 18 pi over 6. So I'm coming the opposite way. I'm coming this way, negative way. Where do I find negative 17 pi over 6? Third quadrant. And what reference angle do I have? How many times is 6 go into 180? 30. Okay? Remember, they can keep going around and around and around. Negatives go clockwise. So I went here. I went to 12 pi over 6. I got to go 6 more, almost to 18. I got to go to 17 because I'm negative. Right? And I think that's the rest of this, right?
Yes.
I have a question.
Yes, question.
I multiplied 17 times 180, right, and then divide by 6. I got negative 5. But to find the reference angle, wouldn't I just add 360 to it?
So subtract 360.
Yeah.
Subtract
And you get
360.
150.
You're going to get negative, oh, well, this
But
is negative.
It's negative. Yeah, I know, but then you know that that's what's
You're going to get negative 150, which will be here. You still have negative 150 left.
Right, you flipped it.
I gave you the negative. And you can absolutely